Welcome, classmates and teacher. Allow me to present the solutions and reasoning behind each item in our exam. This includes the actual examples and brief explanations of concepts such as normal distribution, hypothesis testing, correlation and regression, chi-square, analysis of variance, and Pearson's R. But before we proceed, let us recall the properties of normal distribution. First, the normal distribution curve is bell-shaped. This means the graph looks like a rounded hill or a bell. Second, the mean, median, and mode are equal and located at the center of the distribution. In a normal distribution, the average or mean, the middle value or median, and the most frequent value is mode all occur at the same point. Third, the normal distribution curve is unimodal. Unimodal means it has only one peak. This peak is where the mean, median, and mode are the highest point on the graph. Fourth, the curve is symmetrical about the mean. The left side of the curve is a mirror image of the right side. This symmetry shows that data is evenly distributed around the center. Fifth, the curve is continuous. This means the curve goes on smoothly without breaks or gaps. 6. The curve never touches the x-axis, or this is what we call an asymptotic. 7. The total area under the normal distribution curve is equal to 1 or 100%. This means that the entire curve represents 100% of the data. Since the curve is symmetrical, there is 50% of the data on the left side of the mean and 50% on the right side. Here is the figure on the said properties. Now, here are the 5 samples of normal distributions. In order to find the area between two z-scores, we can also use the z-table or standard normal table. Find the area under the standard normal distribution curve between 0 and 0.85. How did we get this? Using the z-table, go down the left-hand column, labeled z to 0.8, then go across that row until the column 0.05. If we add 0.8 and 0.05, that will be 0.85. The number in the table 0.3023 is the area under the standard normal curve between 0 and 0.85. Since the z-score is positive, the shaded region is on the right side of the mean. Second sample, find the area under the standard normal distribution curve between negative 1.5 and 0. To get this area, we are using z-table. Apply the fact that the standard normal curve is symmetric about 0. First, find the area between negative 1.5 and 0. Go down the z column to 1.5 and then across that row until the column 0.00. If we add 1.5 and 0.00, that will be 1.5. The number in the table is 0.4332. By symmetry, the area between negative 1.5 and 0 is also 0.4332. Although the z values can be negative, areas must be positive. Third sample, find the area under the standard normal distribution curve between negative 1.81 and 2.42. To find the area, simply add the area between negative 1.81 and 0 to the area between 0 and 2.42. Using the z-table, the area between negative 1.81 and 0 is 0.4649, and the area between 0 and 2.42 is 0.4922, with a total area of 0.9571 or 95.71%. Now, the fourth and last sample for normal distribution is finding the z-value corresponds to the given area. Using the z-table, we look for the area value 0.4357 within the body of the table, and then identify the corresponding z-score from the row and column headers. For 0.4357, you would find it associated with a row of 1.5 and a column of 0.02, and it will give us a z-value of 1.52. Since the shaded region is on the left side, the C-value will be negative. Therefore, the C-value of 0.4357 to the left side of the mean will give us a result of negative 1.52. And the last is finding the C-value corresponds to 0.4066 to the right of the mean. Using the C-table, we look for the area value 0.4066 within the body of the table, and then identify the corresponding C-score from the row and column headers. For 0.4066, you would find it associated with a row of 1.3 and a column of 0.02, and it will give us a C-value of 1.32. Since the shaded region is on the right side, the C-value will be positive. Therefore, the C-value of 0.4066 will give us a result of 1.32. Next is a sample of hypothesis testing. The problem, a company claims that their battery lasts 10 hours on average. A sample of 16 batteries has an average of 9.5 hours with a standard deviation of 1 hour. At alpha equals 0.05, is there enough evidence to say the average is different? First step, state the null and alternative hypothesis. The null hypothesis states that the mean is equal to 10. The alternative hypothesis states that the mean is not equal to 10. Because it says different, this is a total test. Second step, select the level of significance. The level of significance in the problem is alpha equals 0.05. Third step, determine the critical value and the rejection region. The significance level is 0.05. The not equal sign in alternative hypothesis indicates that the test is two-tailed with two rejection regions, one in each tail of the normal distribution curve of sample mean. Because the total area of both rejection regions is 0.05, the area of rejection in each tail is 0.025. The critical value now is positive negative 1.96. Fourth step, state the decision rule. We have to reject the null hypothesis if the critical value is greater than 1.96 or less than negative 1.96. Fifth step, compute the test statistic. We have a formula of C equals the sample mean minus the population mean divided by the standard deviation over the square root of the sample size. Let us substitute Z equals 9.5 minus 10, which is negative 0.5, divided by 1 over the square root of 16, which is 0.25. Then negative 0.5 divided by 0.25 equals negative 2.00. And the last step for hypothesis testing is making a decision. Since Z equals negative 2.00 and this is less than negative 1.96, it falls in the rejection region. Therefore, reject the null hypothesis and conclude that the average battery life is different from 10 hours. Now, let us explore correlation and regression with one sample. Construct a scatter diagram and find the relationship between the variables x and y. A manager wishes to find out whether there is a relationship between the age of his employees and the number of sick days they take each year. The data for the sample follow. We have here the row for the age of employees and the row for the number of sick days. To construct a scatter diagram, we can use a spreadsheet, and this is what the graph looks like. We will notice that the line slopes downward from left to right. Therefore, the relationship between the two variables is what we call the negative linear relationship. Let's move on to a sample chi-square test. A teacher believes that students choose their favorite school subject equally. She surveys 60 students and their choices are math, science, English, Filipino, and Araling Panlipunan. First step, state the hypothesis. The null hypothesis, students prepare all subjects equally. And alternative hypothesis, students do not prepare all subjects equally. Second step, find the critical value. To find the critical value, we first compute the degrees of freedom. Degrees of freedom is equal to n minus 1, where n is the number of categories. Substitute the number of categories, which is 5 minus 1, equals 4. Next, we check the chi-square table at a significance level of alpha equals 0.05 and with 4 degrees of freedom. At alpha equals 0.05 and degrees of freedom is equal to 4, the critical value is 9.488. This means if our computed test value is greater than 9.488, we will reject the null hypothesis. Third step, to determine the expected frequency, we divide the total frequency by the number of categories. The total frequency is equal to 60 and the number of categories is equal to 5. So we divide 60 by 5 equals 12. Therefore, the expected frequency for each category is 12. Fourth step, to compute the chi-square statistic, we subtract the expected frequency from the observed frequency. Square the result, then divide it by the expected frequency. We do this for each category. After calculating each value, we add them all together to get the chi-square statistic. This value will be compared to the critical value to determine whether to reject the null hypothesis. It gives us the result of 4.6666. Last step, the decision is failed to reject the null hypothesis. Since 4.6666 is less than 9.488, therefore, there is not enough evidence to say that students have different preferences. Next, a sample of ANOVA, which stands for Analysis of Variance. This method is used when we want to compare the means of 3 or more groups to see if there is a significant difference among them. In this case, a company wants to find out if 3 different training programs affect the average employee performance test scores. The employees were randomly assigned into 3 groups, and the significance level is set at 0.05. Our goal is to determine whether the training method has a significant effect on performance. Here are the test scores for each group. Now, we start by stating our hypothesis. The null hypothesis, the mean scores of all groups are equal, and alternative hypothesis, at least one group mean is different. Next, we use a significance level of alpha equals 0.05. Next, we calculate the degrees of freedom. The degrees of freedom for numerator is equal to k minus 1, where k is the number of groups. As we look back on the problem, we have 3 groups, Group A, Group B, and Group C. So 3 minus 1 equals 2. Let's check out the degrees of freedom for denominator. Degrees of freedom for denominator is equal to n minus k, where n is the sum of the sample sizes of the groups. Let's take another look at the problem. We have 12 sample sizes minus the number of groups of 3. The degrees of freedom for denominator is 9. To get this critical value, I have here an F table for the significance level of alpha equals 0.05. Now, the critical value is 4.26. Our decision rule is to reject the null hypothesis if the computed F value is greater than 4.26. Now, we will compute the F-test statistic. Based on our calculations, the sum of squares between is 279.5, the sum of squares within is 26.75, the mean square between is 139.75, the mean square within is 2.972, and the F-test statistic is now 47.02. Our conclusion, since the computed F value of 47.02 greater than 4.26, we reject the null hypothesis. Therefore, there is a significant difference in the average test scores among the 3 training methods. Lastly is a sample of Pearson's R. Pearson's R is a measure of the strength and direction of a linear relationship. The problem, a marketing executive wishes to determine whether there is a relationship between the number of television commercials aired per week and the number of sales of a product. The data for the sample follow. We have here the row for the number of ads and the row for sales. It will be easier to solve for R if a table of values will be constructed. Find the values of xy, x squared, and y squared, and place these values in the corresponding columns of the table. Now, the summation of x is equal to 45, summation of y equals 38, summation of xy equals 338, summation of x squared equals 401, and summation of y squared equals 286. Let us solve for the sum of the products of the deviations of x and y is equal to 53. Sum of squares of deviations of x is equal to 63.5. And sum of squares of y is equal to 45.33. Now, substitute and solve for r. It will give us the result of 0.988. Therefore, the relationship between the number of TV ads and sales is very strong positive linear. As I end this presentation, we have explored the major topics in statistics, from understanding distributions to making decisions through hypothesis testing, analyzing relationships using correlation and regression, and applying tests like chi-square, ANOVA, and Pearson's R. Thank you for listening.